When we talk about forces acting on an object, we often think about their size, the strength of the push or pull. However, to truly understand how these forces interact, we must also consider their direction. This is because force is not just a scalar quantity, it is a vector. A vector is defined by both its magnitude and its direction. Imagine trying to describe a journey without specifying whether you're heading north or south. The same principle applies to forces. Without direction, the size of a force alone can be misleading. Let's break it down. Magnitude refers to how strong the force is, usually measured in newtons. If I push a box with a force of 10 newtons, that tells us how much effort I'm applying. But if I don't specify that I'm pushing it to the right, the information is incomplete. The box might not move at all if there's another force acting on it in the opposite direction. This is why it's crucial to consider both magnitude and direction when analysing forces. Now, let's explore the concept of contact and non-contact forces. Contact forces are those that require physical interaction between objects. Think about friction, tension, and normal force. When I push that box, my hand is in direct contact with it. The force I exert is a contact force. If I were to apply a force of 10 newtons to the right, and there was a friction force of 5 newtons acting to the left, the net force on the box would be 5 newtons to the right. Here, both the size and direction of each force are pivotal in determining the box's movement. On the other hand, non-contact forces operate without physical contact. These include gravitational force, magnetic force, and electrostatic force. For instance, consider gravity. The Earth exerts a gravitational force on an object, pulling it towards its center. This force has a magnitude which depends on the mass of the object and the distance from the center of the Earth, but it also has a direction, downward, toward the center of the Earth. If you were to drop a ball, it accelerates downward due to the gravitational force acting on it. Understanding the interplay between contact and non-contact forces is essential in the study of physics. When you throw a ball, the initial force you apply to it is a contact force, propelling it forward. However, once the ball is in the air, it is primarily under the influence of non-contact forces, such as gravity and air resistance. If we only considered the initial force without acknowledging the gravitational pull acting downward, we would have an incomplete understanding of the ball's trajectory. Moreover, when multiple forces act on an object, we must analyze the net force. This is the vector sum of all the individual forces. If two forces act in the same direction, we add their magnitudes. If they act in opposite directions, we subtract their magnitudes. The direction of the net force determines the acceleration of the object according to Newton's second law, which states that force equals mass times acceleration. In summary, when discussing forces, it's not sufficient to focus solely on their size. We must also consider direction, as force is inherently a vector quantity. Understanding the distinction between contact and non-contact forces, as well as how they combine to create net forces, is crucial for predicting and explaining the motion of objects. Whether you're pushing a box across the floor or watching a satellite orbit the Earth, recognizing both the magnitude and direction of forces will allow you to grasp the fundamental principles of physics that govern our world.